Hello everyone, good evening. So here we shall solve the sub parts 4, 5, 6, and 7 in the uh, question number 15 in the exercise 1 of the chapter Trigonometric Identities. So in the question number 15 in the exercise 1 in subpart 4, it has been told that we have to prove that sec power 6 theta is equal to tan power 6 theta plus 3 tan square theta into sec square theta plus 1. So here the left hand side has been told that it is sec power 6 theta. So now this we can write it as secant square theta whole cube whole power 3. And we also know that secant square theta is equal to 1 plus tan square theta. So we can write it as 1 plus tan square theta whole cube. And as we know, a plus b whole cube, that is equal to a cube plus b cube plus 3a square b plus 3ab square. So that formula only you have to use it here. So 1 cube is 1 plus tan square theta whole cube plus, or we can also write it as a cube plus b cube plus 3ab into a plus b. That also you can write. That will be 3 into ab, that is 3 into tan square theta into 1 into 1 plus tan square theta. So now this will be equal to 1 plus tan square theta whole cube means tan power 6 theta plus this 1 plus tan square theta, again I can write as secant square theta. So this will be equal to 3 tan square theta sec square theta, which is obviously equal to the right hand side. So hence 2. Then in the part 5, it has been told that we have to prove that the left hand side, which is 1 minus sin theta plus cos theta whole square, that is equal to 2 into 1 plus cos theta into 1 minus sin theta. So now therefore the left hand side has been told out, that is 1 minus sin theta plus cos theta whole square. So that will be equal to so you can apply the formula for a square plus a plus b plus c whole square. So that is equal to, given as we know that a square plus b square plus c square plus 2ab plus 2bc plus 2ca. That only we can apply. So a square, that is 1 plus sin square theta plus cos square theta plus 2ab, that is minus 2 sin theta, and plus 2bc, that is plus of minus 2 sin theta cos theta, plus 2ca, that is plus 2 cos theta. This will be equal to 1 plus the sin square theta plus cos square theta, we know that is equal to 1. So 1 plus 1 is 2. So 2 minus 2 sin theta minus 2 sin theta cos theta and plus 2 cos theta. So now we can take 2 as common from the first two terms. Then we will get 2 into 1 minus sin theta. And from the next two terms, we can take you can also take plus 2 cos theta as common, and then we get 1 minus sin theta. This will be equal to 2 plus 2 cos theta into 1 minus sin theta. So from here 2 I can take as common offset. So this will be 2 into 1 plus cos theta into 1 minus sin theta, which is equal to the right hand side. So hence 2. Then in the sixth part, it has been told that sin power 4 theta minus cos power 4 theta plus 1. But so that we have to prove it as equal to 1, sorry, sin power 4 theta minus cos power 4 theta plus 1 into cosec square theta, that is equal to 2. So now on the left hand side, it has been told that it is sin power 4 theta minus cos power 4 theta plus 1 into cosec square theta. Cosec square theta. So this will be equal to, now cosec square theta we can write as 1 by sin square theta. So this will be you can also write this sin power 4 theta minus cos power 4 theta as sin square theta minus cos square theta into sin square theta plus cos square theta. Since a square minus b square is a plus b into b, and this plus 1 into 1 by sin square theta. Now this will be equal to 1. So this is actually sin square theta minus cos square theta plus 1 into 1 by sin square theta. Now this is actually sin square theta plus, I can write 1 minus cos square theta into 1 by sin square theta. Now we know that sin square theta we can also write it as 1 minus cos square theta. That is 1 minus cos square theta we can write as sin square theta. So sin square theta plus sin square theta, that will be 2 sin square theta into 1 by sin square theta. So this will be equal to 2 sin square theta divided by sin square theta. The sin square theta will get cancelled, so that is equal to 2, which is equal to the right hand side. So that is good. Then in the sixth part has been told, okay, this was the sixth part. Okay, so the seventh part, the seventh subpart, it has been told that we have to prove that sin power 6a plus 3 sin square a into cos square a equals to 1 minus cos power 6a. So this we have to prove. So in the left hand side, it has been told that it is sin power 6a plus 3 sin square a into cos square a. So now this will be so sin square a, we know that we can write it as 1 minus cos square a. With this we can write it as 1 minus cos square a, since while so this sin power 6a we can write as sin square a whole cube plus this will be the sin square a into cos square a. So this sin square a will be write as 1 minus cos square a whole power 3 plus 3 sin square a. And sin square a, this sin square also again you can write as so 1 minus cos square a into cos square a. So this will be, you know that a minus b whole cube, that is equal to given as a cube minus b cube minus 3ab into a minus b. So this will be a cube 1 minus cos square a whole cube minus 3 to ab, so 3 into cos square a into 1 minus cos square a. Then minus this will be 3 cos square a, then minus 3 cos power 4a. This will be 1 minus cos square a whole cube means 1 minus cos power 6a, minus this will be 3 cos square a, plus this will be 3 cos power 4a, plus 3 cos square a, minus 3 cos power 4a. So minus 3 cos square a plus 3 cos square a will get cancelled, and plus 3 cos power 4a minus 3 cos power 4a will get cancelled. So this will be equal to 1 minus cos power 6a, which is equal to the right hand side. So thanks. So hope all of you understood all these 4 subparts of the Question number 15. Still, any doubts if you have, please write that in the comments. We should obviously clarify them. So thank you, everyone. Bye.